Hi, good day to you all. Welcome to another physics class. So today we'll be talking about transformer. Transformer. Something that is transforming something. Just the way I'm transforming you guys to become good scientists. So I'm a transformer. Okay, so transformer. You might have heard of the word. Maybe at home, in your area, your place of work, company, institutions, transformer. So I'm here to tell you what a transformer is. Now, a transformer is like a device that is used to step down or step up an alternate voltage. Now, you have a machine and you want the machine to work at a particular speed, volt, and current. Now, you will need that transformer to help you regulate the influx of current going into the machine. That is why we said it helps to step down or step up the voltage. This stepping up, stepping down is the transforming aspect, the regulatory aspect of the transformer. Now, the transformer is made up of a core that has like an E shape. Yes, I think it's like an E shape. So this core helps to regulate or convert alternate current that has high voltage, it's converted to a low voltage, or the voltage that is low, it helps to convert it to a high voltage, depending on the requirement of the machine the transformer is attached to. Now, all this step up, step down, voltage, current, you might have heard of it during your physics class on electricity. So it shouldn't be new to you. So now, in a transformer, there are two coils. We have the primary coil and the secondary coil. Now, if you see winding in another terminology, it's still the same thing. We can have the primary winding and the secondary winding. So now, this primary coil, secondary coil also have their various currents, their voltage, as well as their number of windings or number of turns. So now, in a nutshell, we can represent this transformer, the operation of a transformer, in an equation. E represents the electromotive force or the voltage. The voltage in the secondary coil over the voltage in the primary coil is equal to the winding or the number of turns in the secondary coil over the number of turns in the primary coil. Remember I said the transformer has both the primary and the secondary. So whatever you want to do to the secondary, you must also put the primary into consideration. Now, as we have this voltage and number of turns, we also have the current. So how does this voltage relate to the current? ES, that is that of the secondary, times current in the secondary equals to the what? The EMF in the primary times the current in the primary. When you're talking about number of turns, ES over EP equals NS over NP. But when you're talking about the current, it's going to be ES IS equals to EP IP. The P is the primary coil. The S is the secondary coil. Is that taken? Now, when we're talking about the output and input power, whenever you see the power output, we are referring to the secondary. The power input, we are referring to the primary. So here, in a nutshell, we are talking about the EMF of the secondary times the current of the secondary. For the input, it is EMF of the primary times current of the primary. Is that explanatory? Now, let's look at this example. A step-up transformer. Yes, this one is stepping up. A step-up transformer operates on a 220 volts and supplied a current of 10 amperes. The ratio of the primary and secondary winding, the coil, the number of turns, is 1:10. Calculate 1, the voltage across the secondary, the current in the primary, and the power outputs. Now, let me this off. I want us to be looking at the question while we solve for proper understanding. Now, let us first of all write out our parameters, which is what I always tell you to do. Anytime you are given a question, be it physics or chemistry, write out the parameters given to you. It will enable you to know, what am I looking for? What were we given? Now, what are the given parameters? Here, we were given the volt, which is the EMF in the primary. So we have EP equals to 220 volts. So we are looking for what? ES. Good. The ratio of the primary and secondary coil. Primary is what? NS. So we have our NP. NP over NS equals to 1 over 10. Good. Calculate the voltage across the secondary, which is this one. The current in the primary, which is the what? IP is unknown. YIS is given to us as 10 amperes. Then the last one is the power output, which is the what? The power in the secondary. So let's start. The first one is the ES. Okay, we already have our formula here. ES. Let's start with EP over ES equals to NP over NS. So what is our EP? 220 volts. We are looking for our ES. What is NP ratio NX? We've been given as 1:10. We were given as 1:10. So here, cross multiply. Our ES equals to 220 times 10. And that will give us 2,200 volts. That is the volts in the secondary. We have answered the first question. That is the volts in the secondary. 2,200 volts. Now let's go to the second question, which says find the current in the primary. Remember, I gave you an equation that ES, IS equals EP, IP. Is that taken? Now, we are looking for the current in the primary, which is our IP. What is our ES? That is what we just found here. 2200. What is our current in the secondary? Fair. What is our EP? EP is what? 220. And we are looking for IP. Let's rub this off. I want us to still look at the question. So now, if you make your IP the subject of the formula, you'll be having something like this. IP equals 2200 times 10 over 220. Yeah? Yeah. So our IP is 100 amperes. That is the current in the primary. I can see that. That is the current in the primary. Now for the last question, which is our power output. Remember, I told you that power output has to do with the secondary. And the power output equals to what? ESIP. What is our ES? Sorry, ESIS. So what is our ES? 2,200. What is our IS? 30. So altogether we are having 22000. Who can tell me the units of power? Watts. Beautiful. Watts. Good. Yeah? Look at it well. EP, the EMF in the primary. ES, the EMF in the secondary. If you want to relate the primary coil to the secondary coil, you'll be given an equation, ES over EP equals to NS over NP. The N stands for the number of turns in both coils. Now, related to currents, we have EP, IP equals to what? ES, IS. S stands for secondary, P stands for the primary. When you're talking about the power output, you're referring to the secondary coil. And everything in the secondary is what? ES, IS. When you're talking about the input power, we are talking about the primary core, which is what? EP, IP. Is that understood? Alright, so continue next class. Bye.